Let's talk about section 4.3, distinguishing among atoms. And so we know that all of these are dogs and they come in different varieties. Well, so do atoms. And so we're going to talk about how they are alike and how they are different. Atomic mass and mass number are two ways that we can tell atoms apart. So, elements are different because they have a different number of protons. So, carbon has 6 protons. Neon has 10. They are different because they have different atomic numbers. And so the atomic number is a unique identifier for an element. Here are the first 10 elements with their atomic numbers. And in fact, the periodic table is arranged by increasing atomic numbers. We start from hydrogen to helium, and on we go. You do not have to memorize any of this. You should remember, however, that protons and electrons are always the same in a neutral atom. However, the mass number can vary. So, atomic numbers, the number of protons and electrons, since the positive charge must equal the negative charge. Understanding atomic number. So nitrogen has an atomic number of 7. So you should be able to tell me how many protons and electrons it has right now. And that would be 7. Total number of protons and neutrons would be the mass number. These are the two particles that have a sizable mass. Electrons are extremely light and do not add up to any part of the mass. In fact, it would take 1,840 electrons to equal 1 proton. So, and there's no elements with that many of electrons. So if you know the mass number and the atomic number, you can figure out how many neutrons there are, because the number of neutrons in an atom is the difference between the mass number and the atomic number, or protons plus neutrons equals mass for any isotope. What you see on the periodic table, however, is not an isotope's atomic mass. It's an average of all the isotopes. So, number of neutrons equals mass minus atomic number, or protons. Composition of elements can be represented in a shorthand notation. The atomic number is the subscript or the bottom number, and atomic mass or the mass number is the top number or superscript. You can also refer to it by writing out the element name, then a dash, and its atomic mass. So gold 197 would also be a way of notating this. So you should be able to do this question now. I'm going to ask you to pause the video here and see if you can come up with the right answers and kind of check yourself just to make sure you're good. Okay, going on. Beryllium-9 would have 4 protons, 4 electrons, and 5 neutrons. Neon-20 would have 10 electrons, 10 protons, and 10 neutrons. It does not have to have the same number of protons, electrons, and neutrons. Neutrons can vary, but protons and electrons must be equal, unless it's an ion. Sodium-23 would have 11 protons and electrons and 22 neutrons. What information is needed to determine the composition of a neutral atom of any element? Well, you have to know the atomic number and mass number. If you're given the number of protons or given the number of electrons, you would be able to figure out the mass number. If you were given the number of neutrons, you would be able to figure out the mass number, etc. And we did a whole worksheet on that. How do isotopes of an element differ? Well, all of these are neon isotopes, and all of them have 10 protons, and all of them have 10 electrons, but each one has a different number of neutrons. Isotopes are atoms that have the same number of protons but a different number of neutrons. So all three of these are isotopes of neon. If I change the number of protons, I change the identity of the element. If I change the number of electrons, I make it into an ion. And if I change the number of neutrons, I change the isotope. Because isotopes of an element have different numbers of neutrons, they have different mass numbers. Pretty straightforward. So at the beginning we talked about these dogs. So the dog's size and colors may change, but they're still all dogs. If we were looking at breeds, if we look at a poodle breed, all poodles would look very similar, but they would be different in terms of size and mass. So those would be isotopes of the element poodle, so to speak. But if we looked at, I don't know, Great Danes, that would be a different element, have a different mass number, different number of protons. Atoms of one element differ from atoms of any other element. And how are isotopes the same of the same element different? Well, if we know the number of protons, we know the identity of the element. If we know the number of neutrons, we can figure out the mass for that particular isotope, because isotopes have different number of neutrons. Writing chemical symbols. So we write out the name carbon-12. We're indicating this is an atom of carbon and it has a mass of 12. If we say carbon-13, that's saying it has a mass of 13, so it had one more neutron than carbon-12. And so you should be able to write the symbol and out the name notation for any isotope I give you. Why are atoms with different numbers of neutrons still considered to be the same element? Well, the identity of the element comes not from the number of neutrons, but comes from the number of protons. And the reactivity of an element would be based on its electrons. So we're going to stop here so that we can start with average atomic mass. Talk to you in a bit.